What is friction? Friction is an invisible contact force that appears whenever two surfaces rub together. The surfaces move in opposite directions to one another. Friction tries to slow things down or stop them altogether. Some everyday examples of friction are walking shoes. They have treads underneath them that grip the ground, allowing us to walk without slipping. Or, when we press the brakes in a car, brake pads rub against the wheels, slowing the car down. Striking a match against a rough surface generates enough friction to create a spark and light the match. High or low friction. The bumpier the surface, the more friction there is. The smoother the surface, the less friction. Sometimes there's not much friction, and this can be useful. For example, to help ice skaters glide smoothly across the ice. But sometimes low friction is not useful. For example, it can lead to slipping on icy pavements or cars losing their grip on wet roads, which can be very dangerous. We can increase friction for safety. One way is by spreading rock salt on icy surfaces. Also, designing shoes and car tires for better grip helps to increase the amount of friction. At other times, there's too much friction, and this can also cause problems. For example, machinery parts might wear down through constant rubbing. Sometimes heat builds up from friction, and this can damage car engines. In a disease called osteoarthritis, joint cartilage wears down due to constant friction. To reduce extreme friction, lubricants like oil and grease are used. Oils lubricate machines like car engines. They let the parts move much more smoothly against each other. Managing friction well keeps things running smoothly. Air resistance. Air resistance is a type of friction that tries to slow down objects as they move through the air. Some everyday examples of air resistance are feeling a breeze when riding a bike, or wind blowing through your hair and clothes while you're walking. When air resistance is high, objects slow down quite a lot. Some examples are the force of wind on an umbrella, making it hard to move against the wind, or parachutes, which are actually designed to have high air resistance. This helps them to fall slowly and land safely. Or bulky, wide-load trucks, which can slow down quite a lot due to strong winds on the highway or motorway. All of these objects have a large surface area. Their bigger surface means more space for air to push against. So this creates more air resistance and slows down these objects quite a bit. We can reduce air resistance by using objects with slim, pointed, torpedo-shaped structures. This shape is seen in nature when birds tuck in their wings to dive faster through the air, or when engineers make high-speed trains that can cut through air easily. Aerodynamic sports cars and bicycles also have this torpedo shape, and this makes it harder for air resistance to slow things down. What is water resistance? Water resistance is a type of friction that tries to slow down objects as they move through water. Some everyday examples of water resistance are feeling resistance when first jumping into a pool, or waves slowing down a boat. When water resistance is high, objects slow down a lot. Some examples are water pushing against you when you're trying to run quickly through deep water, or large sea anchors that are used to slow down big ships. Another example is rowers angling their oars to provide the maximum water resistance so that they can be pushed and propelled forward. These objects all have a large surface area. A bigger surface means more water can push against it. More push means more water resistance, and so these objects slow down. We can also reduce water resistance. We can do this by using torpedo-like narrow shapes that allow the water to flow smoothly over and around objects, and this reduces drag. Some examples include fish, which have smooth, pointed bodies to allow them to swim fast, or narrow-fronted racing boats that can cut through water. And finally, speed swimmers can streamline their bodies and wear special swimsuits. What is gravity? Gravity is an invisible, non-contact pulling force between two objects. Gravity pulls objects towards each other's centres. On Earth, gravity pulls objects downwards. It causes things to fall instead of floating upwards. And it keeps us grounded instead of floating off into space. Gravity also explains orbits. It causes planets to revolve around the Sun without flying off. The Moon also orbits Earth due to gravity too. Theories about gravity have changed over time. In ancient Greece, Aristotle had lots of ideas, but he didn't have much evidence. He claimed lighter stuff should fall faster than heavier objects, but he never tested it. Then along came the Italian scientist Galileo centuries later. He proved Aristotle wrong. He suggested that gravity affects all objects equally. Galileo carried out hands-on investigations to drop heavy and light balls at the same time. He found that lighter objects fall slightly slower than heavier objects because air resistance affects them more. But his theory was that exactly the same amount of gravity pulled the heavier and the lighter ball towards the ground. Isaac Newton expanded on Galileo's work. He explained in detail why objects fall to the ground in the first place. He came up with the term gravity and used it to describe an invisible force that pulls objects towards each other. Newton also used maths to make predictions about gravity and its behaviour. In 1971, astronaut David Scott proved Galileo's earlier theory. The Moon has no air, so no air resistance. And when he dropped a feather and a hammer, they both fell at the same speed. This proved that gravity affected heavy and light objects the same. What are simple machines? Simple machines like levers, pulleys, and gears make it easier to lift or move heavy things using less muscle effort. Levers consist of a rigid bar that pivots or rotates around a fixed point called a fulcrum. With the right positioning, a little push down in one place, we call this an effort, allows a heavy load to be lifted up elsewhere. For easier lifting with a lever, the load should be closer to the fulcrum, and the effort should be applied further away from the fulcrum. Wheelbarrows, seesaws, and scissors are examples of simple levers. Pulleys are created by looping a rope over one or more wheels. Here's how they work. When you pull down on one end of the rope, the pulley system creates an upward force at the other end. This is how it helps to lift heavy objects. By looping the rope over more wheels, you increase the upward force. This means you can lift heavier objects with the same amount of effort. A pulley can be used to lift water from a well. A flagpole and also a lift or elevator use pulley systems too. Gears have teeth that interlock with each other. This allows one gear to turn or drive another gear. We often use them to help control and change the speed of a machine. Gears come in different sizes and with different numbers of teeth. A smaller gear turns faster than a larger gear, but the larger gear provides more force. Like levers and pulleys, gears have an effort and a load being moved. Examples of gears are found in wind-up toys, bikes, and cars. Though simple in design, these machines, combined in clever ways, allow us to lift, build, and move objects far beyond our own human strength.